Alright, this is section 1.3. It's linear equations within two variables. It's something that students learn in Algebra 1, a little bit in Algebra 2, or a little bit in Geometry, and mostly in Algebra 2. Algebra 2 does it's heavily weighted. That in Algebra 1, I think it's heavily weighted. So, I've never taught Algebra 1. But either way, students have seen this multiple times, but they always seem to forget it. Slope. That's M. That's rise over run. All I need, add that to my board. That is rise over run. Most students are familiar with that term. So what we have, I like to use with PreCalc we're using more variables. It's y2 minus y1 over x2 minus x1. So that's their y coordinates, and then over. Rise is our y. Run. So rise is our y, up and down. Run is our x. Then we have some lines. We have a vertical line. That's where just x equals a, so it's just straight up and down. That's when slope's undefined. And a lot of students struggled with this idea, I noticed. But vertical line, you take any point, whatever x is, and it's just straight up and down. So you could have, say I have x equals 2, it's 2, 3 is a point on the line. 2, negative 1 is a point on the line, because it's just straight up and down. Then we have a horizontal line, which is this way. Y equals b, that means it's going through the y-intercept. Like the vertical line is going through the x-axis, horizontal line is going through the y-axis. And that's when slope is equal to 0. Alright, so it's very important to distinguish the two. Again, this has the same kind of idea that if y is equal to 2, 2, 4 is a point on this line. 2, 5 is a point on this line. Or, sorry, 5, 2, and then 4, 2. My bad, I got those backwards. My mistake. Then slope-intercept form. This is one where students love the most, where that's what they're the ones they're used to. And it is y equals mx plus b, where m is the slope, and the way to find slope is from up here, same m. You've got to remember y and x are just variables, so you're really not plugging anything into them. And then we have b, that's the y-intercept. Most students are familiar with this form. It is nice. I don't use it that much because I prefer point-slope form. In most cases, you're going to give in a slope and you're going to give in a point, or you're going to give in 2 points, and you have to find it. I like point-slope form because from this point-slope form, you can rewrite it to slope-intercept form. It's much more difficult to go from slope-intercept form to point-slope form. It's much easier to go from point-slope form to slope-intercept form. I push that students remember the point-slope form. That's the reason why. And that is y minus y1 equals m times x minus x1. Again, y and x, you don't plug anything into, but you plug stuff into y1 and x1. The other key concept in section 1.3 is parallel and perpendicular lines. Parallel lines, they have the same slope. So if you have 2 lines that have the same slope, they are parallel. Perpendicular lines, that's the hard part. It's negative reciprocals. And that's a math term, and a lot of students struggle with that. So what I say is, you take your fraction, like AB, and you flip it. So AB, we flip, and we change the sign to a negative. So here's a number example. 2/3, we flip the fraction, that's the reciprocal part, and then we flip the sign, that's the negative part, okay? I'm going to do some examples, quite a bit actually, I think close to 9 examples for you, so let me get them up on the board, and I'll be right back. Alright, the first set of examples that we're going to do is all graphing, and all from the same set of questions, but they vary in terms of how we're going to get there. We want to find the slope and y-intercept if possible, and then sketch the line. So for all these, find the slope, y-intercept, and if possible, sketch the line. I'm going to use 4 different colors because I only have one graph, as you see here. So we're going to use 4 different colors to illustrate what they look like on a graph. So let's start with this one right here. Number 19, it's y equals negative 1/2 x plus 4. So what I'm trying to get students to do is recognize what the slope is, also recognize what they have. This is easily in y equals mx plus b. So our slope, and slope is whatever number is tied to the x in front of it, either multiplied or divide. That's tied with it, okay? So our slope is m equals negative 1/2. And our y-intercept is, that's, if we remember in section 1.2, that's if we set x equal to 0, we can find our y-intercept. Of course, if we could do that, we do some mental math. 0 times negative 1/2 is just 0. So our y-intercept, or our b, equals 4. Again, this is our y-intercept. So let's go over to our graph and plot it. So our y-intercept is 4, so we're going to count up 4, put a point, and our slope's negative 1/2. That means it's going to point down instead of up. So we have two ways to do it. We can go down 1, right 2, as long as one of those is negative, or we can go up 1, left 2, if it's still negative. So then we just kind of connect the dots like so. As you can see, I'm not a very good artist, but it looks something like that. Okay, I'm not a big fan of graphic. Now, let's move on. 23, it's 7x plus 6y equals 30. So, in this case, get y by itself. Solve for y. Let's go ahead and move the 7x over. Math practice is to always put the x or their highest exponent first with the x. Okay, so that's why I put it there. We're going to divide everything by 6. Divided by 6 is 5. So now we have this. Our slope is negative 7/6. And our b, or y-intercept, is 5. We can easily see that. So, again, it's negative, so we're going to go up 5 this time. Negative 7/6, we're going to go down 7. 1, 2, 3, 4, 5, 6, 7. Then over 6. 1, 2, 3, 4, 5, 6. And then we'll just kind of, it's going to be a steeper slope. And it looks something close to that. Pick bad examples, I guess. My bad. Moving on. Next is y minus 3. Again, there's no x in here, but so let's solve by y. So, or just get y by itself. So that means just y equals 3. There is no slope, so slope is 0. That means it's a horizontal line. Going through it, y equals 3. So we're up 3. There's no slope to it, so it's just straight this way and that way. Okay, so what are points? As long as y is 3, and x can be any value. Alright? The last one. There's no y value, so solve for x. So, x equals negative 5. Slope is undefined. This is a vertical line, straight up and down. So let's go to negative 5. We'll go straight up and down. Okay? Students struggle with these two concepts right here. Now, if I notice, I hinted that we're going to talk about parallel and perpendicular lines. These are parallel and perpendicular lines because their slope is 0 and then undefined. Those are reciprocals. They're negative reciprocals if you want to go that far because there's no negative 0 and there's no negative undefined number. So these are parallel lines. As you can see right here, they form a 90-degree angle. So there's the first set of examples. I'm going to erase all this, and what I'm going to show next is what happens when we have given different values. Okay? Alright, so on these examples, what we're going to have is we want to find the slope-intercept form of the equation of the line that passes through the given points and has an indicated slope. So that's these ones right here. Those are the directions for these ones. So we want to write a line that goes through this point and has a slope. So let's start off, and we want it in y equals mx plus b form. So we're given a slope and a point. I'm going to use point slope formula and get to y equals mx plus b. So let's plug it in to point slope formula. So our y minus 6 equals negative 2, because that's our slope, x minus negative 3. Okay? So let's solve for y. Distribute first, so that means we're going to get negative 2x. This is negative times a negative, so it's positive 3 times a negative 2, so that becomes minus 6 equals y minus 6. Add this to the other side, so therefore we get y equals negative 2x, and that's it, because negative 6 plus 6. So this is our answer. That's all you kind of have to do on those kind of questions. Alright, so next, 59. This says 6 negative 1 is m. M is undefined. So when m is undefined, that's a vertical line. We have to remember that. And a vertical line is where x equals something. So whatever x in this coordinate, whatever x is, that's our line. Since it's undefined, we have x equals 6. And that's it. That's all there is to it. Students, you're going to overthink this. Please don't. It's pretty simple. Don't overthink it. If it's undefined, what is the x value that I need to go through? And it's 6, okay? N is 0. Well, that's our next problem. Moving on to 61. It's 4 or 5 halves, and m equals 0. When m is equal to 0, that is a horizontal line. That goes through our y-intercepts, or our y points. So what's the y point we need to go through? 5 halves. So that's just y equals 5 halves. And that is our answer. That's all you have to do on those ones. They trick people up. That's why I did 2 examples of them. Okay, moving on to our next one. 65. 65, our directions say find the slope-intercept form of the equation line passing through the points. So we have 2 points. So we need to find slope, that's our first one, and then we need to plug it into an equation to get our y equals mx plus b form. So slope, again, is just y2 minus y1, all divided by x2 minus x1. So m equals y2, so 5, minus negative 1, all over negative 5 minus 5. Okay, so let's do some math real quick. 5 minus negative 1, that's going to turn into 6. And this can be negative 10. Let's go ahead and reduce that down. 2 goes into both of those, so it would be negative 3/5. That's our slope. Now let's use point slope form. So it doesn't matter which point we use, which set, as long as we're consistent in which we use. So let's go y minus, I'm going to use this one. Plug everything in, just like that. Now solve for y. Get y by itself. This turns into y plus 1, negative 3/5 x, minus times, or actually, so we have a negative times there, so it's going to be plus 5. The 5's cancel out, because imagine this is 5 divided by 1, right? Fractions, we should be doing those. They cancel, so that means we get y plus 1 equals negative 3/5 x plus 3. Subtract the 1 over. So 1 equals negative, y equals negative 3/5 x plus 2. And there is your answer. Okay, so that's the point slope formula. My last example is going to be the hardest problem that I think, and it comes up the most, I think, on standardized tests. It also comes up on my personal test, because it combines all of it into one simple thing, or one big problem. So, let me erase these. I'll go ahead and leave that up for if you're still copying it. Of course, you can just pause it and get it. So the number we're doing, number 87, it's going to be 4, this is what they give us, 4x minus 2y equals 3, and 2, y. So, what this problem says is, given a line, we want to find the slope of that line. We want a line, given that line, and given a point. We want a line that's parallel to this line going through this point, and a line that's perpendicular to this line going through this point. So let me write that up here on my instructions. So part A, we want a parallel line. Part B, perpendicular line. That's what we want. So part A, well actually the first thing you do, before you do anything, find the slope of this line. Okay, so you're not going to mess with that point. Find the slope of the line given, so that is solve for y. So I'm going to do it right here. Let's move the 4x over, so we get negative 2y equals negative 4x plus 3. Divide by negative 2. Everything gets divided by negative 2, so y equals negative 4. Negative 4 divided by negative 2 is positive, and it's going to be positive 2x plus, or sorry, minus 3/2. I don't really care about this. All I really care about, I'll circle it so we know, all I care about is this number right here, because I need the slope. Because I want a line that's parallel to this line, it goes through that point. Parallel, they have to have the same slope. So let's do part A. I take my slope, which is 2. I'm going to take my point, and I'm going to plug it into point slope formula. So y minus 1 equals 2x minus 2. So now let's solve it. So y minus 1 equals 2x minus 4. Move the 1 over. Y equals 2x minus 3. That's our answer for a parallel line. You see how they're different intercepts, but they have the same slope. So this is an answer for part A. So part B, perpendicular lines. We have to get a negative reciprocal. So if our m, our case, this m is 2. There's negative reciprocal of that. Imagine that's 2 divided by 1. If I want the reciprocal, that's going to be negative 1/2. Because remember, we flipped the fraction and changed the sign. So now we're going to use this as our slope. Still use this same point. So basically we just do the same thing like we did up here, except that 2 becomes negative 1/2. So y minus 1 equals negative 1/2 x minus 2. Alright, let's go ahead and solve through. So y minus 1 equals negative 1/2 x. Negative 1/2 times negative 2. The 2's cancel, but they change to a negative, so plus 1. Add the 1 over. Y equals negative 1/2 x plus 2. And that is our answer for perpendicular lines. This problem right here is the one that stumps students the most, because it's multiple parts, and you have to. The problem is they freak out with this because they think this intercept. They think all they have to do is just change that, and it's parallel. But they have to go through this point. They have to go through this point 2, 1, and that's the problem that students have. They forget that they have to go through a certain point. Then once they get that, they freak out because they have to flip the slope here, and that's why it's really challenging to make sure students get that. But once they get that, they'll be so much better, and then they can start learning some math terms. That's it for 1.3. Hopefully this helps.